Welcome to the module 3 of data analytics, where we are going to talk about NumPy, that is the abbreviation of numerical computing with Python, as the name suggests. So basically we are going to perform some mathematical thing on by using programming. Obviously, when you're working with analytics, you're supposed to work with statistics, obviously a lot of statistics. So working with statistics means that you need to work with numericals, and working with numerical means that Python has a very beautiful package called NumPy to work with. So let's see what it is. So our goal is, first of all, we'll see what and why. So what is basically NumPy and why we have to use NumPy. Then we'll be talking about NumPy arrays. You might be wondering that what is this word array. So whatever you can say, whatever the meaning of list, the list data structure that we have been using so far in Python, that is translated as array in NumPy. You might be wondering that, okay, if it is the same thing, list and array are the same thing, then why don't we just use list? Wait for the answer. I'll answer to this question in next slide, right? So then we'll be talking about n-dimensional arrays. We have multi-dimensional arrays as well. We'll be talking about how to slice or index the arrays, the NumPy arrays. We'll be talking about filtering the arrays, and finally we'll conclude this module by talking about mathematical functions that are available in NumPy. There is a whole range of mathematical functions that are available in NumPy, so we'll be talking about those mathematical functions as well. So first of all, let's answer the question, what is NumPy? So NumPy is basically a Python library, just like pandas that we have used in last module. So it is a Python library that used for working with arrays. Now I have underlined arrays because I wanted to talk about arrays a little bit more. So basically, array is a data structure that is available in NumPy. You might be wondering, you might have heard this word about a lot of other programming languages, because it is available for C++, for Java, for JavaScript as well. But in Python there is no array, there's only list. But array facility comes from NumPy, the package NumPy. Okay, so what is the difference between array and list? So basically, array is at least 50 times faster than list, right? So list is slower comparatively, and array is faster. So you might be wondering that then why we are using list in Python, not arrays. Let's answer this question in next slide. So basically, NumPy is a package which contains different classes, different functions, different variables, and a large number of libraries of mathematical functions, basically, to work with scientific calculations. NumPy can be used to create n-dimensional arrays. We'll first see what is n-dimensional, and then we'll see how to create these n-dimensional arrays, where n is any integer, which means that n can be 100. So we will be able to create 100-dimensional arrays as well, or maybe more than that. We can create 1-dimensional array, 2-dimensional array, 3-dimensional array, and up to n-dimensional, again, where n is any positive integer, right? Now, why NumPy? I've already given an answer to this question, that lists are comparatively slower, and arrays are at least up to, you can say, 50 times faster, not 50%, remember, it's 50 times faster than the traditional list. But the data storage mechanism of list is comparatively better than arrays. And if we talk about speed, then speed of array is in no comparison with list. Speed of array is very faster, but its data storage mechanism is a little bit, you can say, not very optimized as compared to list. So pros and cons are always there. If you're looking for faster speed, you should go for the arrays. If you're looking for, you can say, very optimized data storage structure, then list is the one, right? But mostly when you're working in data science, you have a lot of data to work with. You usually fantasize about having faster speed. So usually the data scientists or data analysts, the first choice of data structure is NumPy. So basically, arrays are very frequently used in data science, where speed and resources are very important. Cool. Okay, so talking about n-dimensional arrays, n can be any integer, any positive integer starting from 1 up till any positive number, 1 2 3 4 5 6 7 8 9 10. Let's just talk about 1D array. So 1D array is just like list. Visually it is just like list. You can store sequence of different elements in it, but its speed is faster, and behind the scenes in the memory, its storage system is a little bit, you can say, its storage system is not as good as the storage system of list, but we are looking for speed, so let's go ahead with arrays. So if we go to our coding environment, and first of all let's import NumPy as NP. If you remember, in previous module we imported pandas as PD, right? So here we are importing NumPy as NP. Again, you can use any alias over here, but overall in the community, NumPy is the alias for NP is the alias for NumPy, right? And again, if you have not installed this library yet, all you have to do is you have to just say pip install NumPy, and that's it, right? So run this cell and you'll be fine. So I'm just gonna comment it for now. Great, so my library is imported over here, and here now if I say arr1, that is my variable name, I'll say numpy dot array, right? So here inside the array I'll have to pass a sequence that will be converted into array. So I'll say 1 2 3 4 5 6 7 8 9, right? So this is a sequence that I have, and then here I'll say arr1, go ahead and print it out. So here we go. So this list has been this list is now converted into array, and this is one-dimensional array, so I can also check out its dimension as well. So if I'll say arr1 dot ndim, which means n dimension, so it says its dimension is 1. I'll also let you know in next video that how to create multi-dimensional array, or we'll start from 2 dimensions, then 3, then 4, and then so on and so forth. So this is how you can check out the dimension of the array, and also you can, as usual, you can check out the type of the array as well. So if I say arr1, so it is saying that it is nd array, n dimensional array, right? A NumPy array of n dimensions. Cool. So and you can perform a lot of different operations on it, almost all the operations that you can perform on a list. For example, on a list, if you can do something like this. If I want to access, let's say, this first element that is at 0th index, all I have to do is I'll have to do something like this. So it works exactly like that. If I want to access the last element, I can work with the negative indexing as well. I can get the last element. I can also perform slicing as well. For example, if I want to access this chunk of the array that is starting from index number 1 and ending at 2 3 4, let's include this element as well. So I'll start from 1, I'll end at 5. Here we go, 2 3 4 5. So this chunk is added. So slicing principles and indexing principle for 1D array are exactly as similar as they are for the list as well. These principles are a little bit different in multi-dimensional arrays that we will talk about in next video. Okay, so now let's talk about 2D and 3D arrays. And by the way, just for your information, I mean, it's an interesting information. All the images that are available in your mobile phone that are basically this 2D array. I'll also explain this thing in much details, and you can say I'll explain this thing in practically as well. That the information, the images that are available in your mobile phone or in your computer, or you can say almost all the digital images that are 2D array. Right, that are basically behind the scenes, they are 2D array. So let's see what is this 2D array. So if we come over here in our coding environment, and let's go ahead and define this 2D array. So here we'll say arr2 equals to, we'll say numpy dot array, and here we have to pass a list, but this has to be I mean, obviously we need to create a 2D array, so this list should be a combination of 2D lists, right? So this will be one dimension, and this will be the second dimension. So in these arrays, we'll say, let's say we'll have 11 12 13 14 15, right? And here let's say we'll have 22 23 24 25. Cool. Oh, let's have 21 as well, just for to follow the convention. And here we'll say arr2, output arr2. So here we go. So it is almost like a row column structure. So these are the rows, and here the vertical things are columns. So this is a 2D array basically, and probably next module I will try to link how this 2D array can be converted into image, right? And also almost in every mobile phone or you can say photo editor, we can crop an image. So I will write a code in next module that by using this NumPy that will help us in cropping a photo. So yeah, probably we'll be making an application, a complete application that will help us cropping a photo. Okay, so now how to index this array? Remember, if I'll say ARR2, so here this colon sign represents the slicing operator, right? And comma sign basically represents the dimension operator. So basically this is a 2-dimension array, and before we go to slicing, let's check out the dimension. So its dimension is 2. Here we go, you can see that, right? Okay, so now since we have a 2D array, so we'll have to separate both dimensions by using comma. So here will be first dimension. So for example, we want to print out, we want to slice from one dimension. Let's say we need these 2 rows. Okay, so these are row number 0 and row number 1. So I'll start from 0 and I'll end on row number 2, because I mean, you know, the second the second value is usually excluded, not usually but all the time it is excluded, so it will include index number 0 and index number 1. Okay, so now let's talk about the columns now. So this is the row dimension, and here we'll be talking about the columns. So we are getting these rows, sorry, we are getting these columns, and now we have to talk about the rows. So we need to get these columns from only this row, or from only this row, or both of the rows. So let's get it from only first row. So I'll put 0 over here. That is my first row. So if I run it, you can see I got 11 and 12, right? And if I make it 1, I'll get 12 and 22. Why? Because this is basically our column 1. This was column 0 and this is column 1. Let me repeat. If I go to 0, you see we are getting 11 and 21. So basically we are getting row number 0 and row number 1. This is row number 0, this is row number 1, and we are getting column number 0, right? And if I do something like this, then guess what is gonna happen? So basically we are getting row number 0 and 1, that is this and this. From row number 0 and 1, we are getting column number 0, 1 and 2. 3 is excluded, right? So you can see this information is available here in output. Cool. And if you will add another, you can say colon over here, then we can have a jump parameter as well, step parameter as well, that we have used in previous lectures. Cool. So this is how we can slice our arrays as well. And if we need any specific element, for example, if we need this 23, so 23 is at row number 0, 1. So this is row number 1 and column number 0, 1, 2, right? So we can simply say, putting a comma, so this is basically row number 1, not 0, row number 1 and column number 2. So 1 and 2. Here we go, we'll get 23. And let me just copy and rewind the code so that you don't miss anything. And let me add another cell over here so that you can get the previous code as well, right? So this is how you can work with 2D arrays. You can slice or index 2D arrays. You can also check out the shape of an array as well. So if I say arr2 dot shape, so here we go, it says it has 2 rows and 5 columns. Cool. Okay, now let's create a 3D array, and we'll see how this 3D array looks like. So we'll say arr3 equals to, so this is again a simple 2D array, and a 3D array will basically be a combination of multiple 2D arrays. If I go back, I rewind the scenes. So what was basically a 2D array? So 2D array was a combination of multiple 1D arrays, correct? Okay, now extend this concept. What is 3D array? So 3D array will be a combination of multiple 2D arrays. For example, here we have this 2D array, right? I'll copy this, and it should be encapsulated in another, you can say another bracket. So this is basically one 2D array, and here I'll put a comma, and I'll again simply just paste it. So it will become a 3D array now. So this is, you can say, one 2D array that is separated by the comma, and this is another 2D array, right? So, and also you can check out the dimensions over here. You can count how many brackets are there, consecutive brackets. So 1, 2, 3, so it's a 3D array. So if I output a 3D array, here we go, it would look something like this. One of the use cases of a 3D array is 3D array can be used to represent, you can say, color images, right? 2D array, this two-dimensional array, is used to represent black and white images, right? And this 3D array, this kind of a 3D array, is used to represent the colored images. I'll talk about this thing in much detail, so don't worry about that. Now, how can we slice this array? The common principle is exactly the same. So we'll have the structure over here, and now since it's a 3D array, so we will have 3 dimensions. So there will be first dimension, then comma, and then there will be another dimension, and then again comma, and here we will have a third dimension, right? One dimension, second dimension, and third dimension, right? So if I simply say from first dimension get me values from 0 to 1, right? Let's make it 2, 0 to 2, and then from second dimension get me values from again 0 to 2, and from third dimension get me value of only 1. What is the output? So basically we are getting 12, 22, which is this one, and again 12 and 22, which is this one. What do we mean by this? It means that it is selecting, this is selecting the depth, or you can say the third dimension. So we are selecting the values from both of 2D arrays, right? It is mentioning this, and then from both 2D arrays, now we are talking about rows and columns. So these are the rows from 0 to 2, which means row number 0, row number 1, and here row number 0, row number 1, and column number 1, right? So this is column number 0, so this is column number 1. So that is why only these values are here in the output, right? Now what if we wanted to output only these values, let's say 12 and 22, not these values? So we can simply have a restriction over here and it will work, right? 12 and 22. And let me again not ruin this for you guys. Let me do it over here. Okay, so now what if I ask you guys to get me an output of, let's say, 13 and 14, right? So first of all, what you have to do is ARR3, you have to create a structure, comma, space, commas. So this will make your you can say imagination very clear. Now here we'll have to add the depth dimension. So for we have to output this 13 and 14, which is in, actually let's make it a little bit different, because this 13 and 14 is similar to this 13 and 14. So let's make it different. So let's make it 113 and 114, right? Run it. Okay, so now we have this 113 and 114, and we need to output this. Okay, so this is in second depth. Okay, so we'll say 1 over here. This is depth number 0, this is depth number 1, so 1 is here. And now what is the row number? This is row number 0, row number 1, so we are talking about row number 0, correct? So row number 0 is here. And now what are the columns? So this is the column number 0, 1, 2, and 3. So column number 2 and 3 are here. So we will say column number from starting number column number 2 ending at column number 4. Again I repeat, last column will be excluded. Here we go, 113 and 114. Cool. So does not matter what is the dimension of array. So this is a 3D array. You can create a 4D array as well. What will be the 4D array? 4D array will just be an extension of a 3D array. Just like 3D array was an extension of 2D array, in 3D array we have multiple 2D arrays. In 4D array we will have multiple 3D arrays, and so on and so forth. So let's say if we will have a 4D array, then how would you index it? You will have, here we have 2 commas, then you will have 3 commas, and that's it. And now you can probably have a 100-dimensional array as well. You can probably have a 1000-dimensional array as well. You might be wondering that, hey, really, do we have that much dimensions of array? The answer is yes, because in data science, in data analytics, when we read data, usually column of data is called one dimension. For example, if I scroll back to the data of previous module, this data that we have used in previous module, if we will perform data analytics over here, this column will be one dimension, this column will be second dimension, right? This column will be third dimension. So here in the previous data we had 14 columns, so here we had 14 dimensions. And believe me, in real cases, when we work with large data set, we usually encounter, you can say, hundreds of columns. So in that case, if data is not large, then you work with NumPy or list does not matter. But when you're working with large data set, speed really matters. That is why we are shifting from traditional lists to NumPy arrays. Let's talk about data filtering by using NumPy arrays. We have already filtered the data by using pandas in previous module, right? So if we have data that is available in, you can say, data frame, we can make use of pandas. But if we have large NumPy arrays and we want to filter out the data, do we have to convert that data first into data frame and then we can filter it out? No. NumPy also provides us the facility of data filtration as well. So let's say here we have this array called ARR1 and we want to filter it, right? We have two types of filter in NumPy arrays. One is called the index filters and second is called the value based filters. So what is the difference? So let me first implement one of those filters. So let's say, and let's talk about the use case first. What if I want to know the indices of all those elements where the values are greater than 12, right? And moreover, this is a sorted array, so let's change it a little bit. Let's make it 140 so that you guys don't, feel bad about it. Okay, so now we have this kind of an array. Okay, and let me run it again. So now I want to fetch the indices of all the elements where the values are greater than, let's say, 12. So simply I'll say numpy dot where, and in where I'll say ARR1, that is my array name, where array is greater than 12. If I run it, here we go. So it says that index number 2, 3, 4, 5, 6, 7, 8, 9. So starting from index number 2, so this is 0, this is 1. So starting from this index, all the elements are greater than 12. Okay, let's make it greater than what? Greater than, let's say, 20 maybe. Then it says that greater than 20 we have only one element, and that is at index number 4. So this is 0, 1, 2, 3, 4. That is 140. And by the way, this is not the value. Again, I repeat, this is the index because we are working on index filter for now. Moreover, you can also perform, you can say, a complex kind of a filter as well. For example, if I want to add two conditions or even more than two conditions. For example, I want to get all the indices where value is greater than 12, but it is maybe less than 17, right? So if I want to add multiple filters, all I have to do is I'll have to write every condition in a separate bracket, and then I'll have to add, I'll have to add the AND sign, and then here we can write the second condition. So we'll say ARR1 is less than what? 17. So this condition will filter out all the elements that are greater than 12. This condition will filter out all the elements that are less than 17, and then this AND operator will take their intersection. Cool. So if I run it, here we go. So it says that index number 2, 3, 5, and 6 is the result. So this is index number 2, 3, 5, and 6 is the result, right? So it has ignored this index because it is what? It is violating this condition. It is not less than 17. You can use AND operator as well, you can use OR operator as well, or whatever kind of operator you want to use, you can. Now this is kind of index based filtering. Now what if you want to create a value based filtering, which means that here the output is indices, but I want the output to be exact numbers. For example, I want to get all the values that are greater than 12. So simple, all I have to do is I just have to replace this where method with something else. So what is that something else? So that something else is ARR1, and then we have to write these two block brackets. right? And here I'll have to put the condition ARR1 is greater than, let's say, 12. I run it. Here we go. So now all the values are available now, right? So this where method will get me the indices, and this index method will get me the actual values that are greater than a certain number. And what if I want to add this kind of a complex structure? I'll just copy this and I'll say ARR1 of, and here I'll paste that complex kind of a structure, and it will get me again the values that are greater than 12 and less than 17. You might be wondering that why it has not included 17, because 17 is equal to 17, not less than 17, right? So if we want to include 17 as well, we can make it as less than or equal. So now you can see 17 is also included, right? So this is how you can filter your arrays. I mean, you can create, these are just two conditions. You can add as many conditions as you want, and here we have worked with AND operator. At your end, you can work with OR operator as well, right? As we discussed earlier, the main usage of this NumPy library is to work with mathematical functions, and it offers a huge range of mathematical functions, and it has, you can say, it divides the mathematical functions into different subcategories. For example, we have basic arithmetic functions, we have exponents and logarithm functions, we have trigonometric functions, we have rounding and flooring and ceiling functions. What else do we have? We have array aggregation functions, we have array operation functions, and finally we also have statistical and random number generator functions. I'll not be talking about each and every functions over here, but I'll be talking about each and every category of the function. So for example, if I'll talk about, let's say, if I start talking about basic arithmetic category, so this provides us the basic arithmetic functions like addition, subtraction, multiplication, division. So I'll be just implementing, let's say, addition or maybe multiplication, and subtraction or division will be left for you guys. So this is the routine that we are going to follow. The function that I will leave, you can consider those functions as an assignment for yourself. So let's get started. So what is this numpy.add method or function? So it basically it performs element-wise addition of two arrays. For example, if we have two arrays, it add both of those arrays element-wise, and it will output one array. What do we mean by that? So let's perform the practical. So let's create first 2D arrays here. So let's say this is not 2D arrays, but two different arrays. Actually, I wanted to say that. Let's say this is array number 1, and here let's create a second array, and this, let's call it array number 2, and let's make it 11, 12, 13, 14, 15, 16, 17, 18, and 19. Okay, so here we have some dummy data over here. So now we wanted to perform addition, so we'll say numpy.add, and here we'll say ARR1 and ARR2. Run it. Here we go. So an element-wise addition has performed. For example, this 1 is added to 11, result is 12, that is here. 2 is added to 12, result is 14, that is here, and so on and so forth. 9 is added to 19, and result is 28, right? So element-wise addition is performed, and a third array is basically an output, and you can store this third array in any other you can say variable as well. So let's say addition equals to something like that, right? And you can also perform multiplication as well. So we'll say numpy dot multiply, and again ARR1 comma ARR2. Run it. So here we go. So 11 is multiplied by 1, answer is again 11. 2 is multiplied by 12, answer is 24, and so on and so forth. Correct? So this is how you can implement arithmetic operators over here. Talking about exponents and logarithms. So basically, for example, let's work on exponent function. So calculate the exponential of all elements in the input array. So and exponential is basically the power functions. So let's say I want to calculate the power of this array. Let's say I want to calculate its square. So what was the function? Function says numpy.exp. So let's say numpy.exp, and here we'll mention the array 1, and its power. Let's say we want to calculate its square, and it gives us error. It says that return arrays must be of array type. Okay. Oh, sorry, actually I merged this exponential function with the power function. So basically exponential function is e raised to the power something, right? So we usually see something like e and then something is written in superscript. So let's say we want to compute e raised to the power 1, e raised to the power 2 or something like that. So if we want to compute exponentials, this is how we can do that, right? So exponential of 1 is this, exponential of 2 is this, and so on and so forth. Moreover, let's say and now let's see how we can compute the power. So we can say numpy dot power, and here we can mention arr1 comma 2, so it will get us the element wise square of the numbers. And if we want to get the cube, this is how we can simply get the cube. Cube of 2 is 8, cube of 3 is 27, and so on and so forth. Cool. Okay, so talking about the other functions that are, and you can work with logarithm function by at your own. Talking about trigonometric functions, so basically if we want to compute the sine of all the elements, or maybe cosine of all the elements, or maybe tangent of all the elements, we can simply use these methods. So let's say numpy dot sin, that is sine. Okay, so we'll say numpy, let me just scroll it up, dot sine of arr1, and here we go, these are the sine, and we can quickly check out the cosines as well. So let's say this is numpy sine, this is numpy cosine, and so on and so forth, right? Okay, these rounding and ceiling methods, basically we use round method in order to round off, you can say, the floating point value. If a value is over 0.5, then it is a number will be added, and if a value is less than 0.5, then a number will be deducted. Floor means that floor, floor is a lower thing. So let's say if a number is 2.9, so that will be floored, which means that will be reduced. And if a number is you want to perform this dot ceil method, it will round up the number, which means that if a number is let's say 2.6, it will become 3. Right, so you can use these rounding and flooring methods at your own. Talking about aggregation method, so basically aggregation means that so far we were working on the methods that are element wise methods, right? So what if I want to compute the sum of whole array? I want to check out the mean or minimum value or maximum value of the complete array. So aggregation functions means that it will get you only one value. Working on the whole array, after working on the whole array, it will get you the one value, right? These are called aggregation functions. Let's go ahead and perform sum and find minimum and maximum values from the array. Okay, so here let's say numpy dot, let's say sum and arr1, right? So the sum is 45. Now you might confuse this numpy dot sum method with this numpy dot add method. This add method actually adds element wise it adds two arrays element wise. On the other hand, this sum method performs aggregation on whole array, right? So if we add up all the elements of arr1, let's say arr1 is here, if you add up all the elements, you can check it out at your end, the sum will be 45. And if we want to check out the mean, we can simply say mean of arr1, and here we go, the mean is 5. We can also check out the minimum value of arr1, and that is 1, right? This one. And you can also check out the maximum value as well, that is 9. Cool. Okay, talking about array operations, you can perform, you can say dot product and transpose as well, right? Transpose means that the whole array will be reversed. Dot product is we have used in mostly physics, where we basically perform we take product of two vectors, or you can say of two matrices as well. Talking about statistical functions, we can check out the mean, we have already checked out the mean. We can check out the median of an array. We can check out the variance and standard deviation as well. What is the variance and standard deviation? This is something that we are going to talk about in probably last module, right? So we'll check out this variance and standard deviation in last module. Finally, you can also generate random numbers by using NumPy as well. These random numbers sometimes help you out in generating some dummy data or something like that. So let's see how we can generate these random numbers. So in NumPy, we have a module called random, and random has different methods. So let's see how we can generate the random numbers. So yeah, here we go. In NumPy, that is NP, we have random, and then random has different methods in it. For example, this rand_n, this will generate random numbers with normal distribution. This rand_int will generate random integers on and obviously you have to provide some range. For example, I want to generate random integers from range 10 to 20, right? And if I run it, so it has generated a random number 10. If I run it again, it has generated a random number 12. If I run it again 10, and so on and so forth. Now 17. Let's say if I extend this range from 10 to 200, here we go, 184, 49, and so on and so forth. So you can generate different random numbers by using these ranges as well. And if you want to you want to get different random numbers depending upon normal distribution, then you can make use of method rand_n, right? That is this one. So that's all. That's about it about mathematical function, about NumPy. I know I skipped a little bit. I skipped a few details about let's say 2D arrays or 3D arrays that I promised you guys that I will practically implement those things in next module, that is our data visualization module. So in data visualization, obviously we will perform data visualizations as well, but I will also show you some magic of NumPy library with the combination of data visualization libraries.